in the plane of XY plane. So here it is not. I'll say that this fellow is making some angle, right? Got it? What I mean to say is that is your velocity. So now, suppose I'm taking this XY plane as this board only, no Z axis. XY plane only we'll be dealing with. And we'll say that this board, plane of the board is your XY plane. You can imagine, like, just in front of that, you are having the vertical wall. So that is your XY plane, correct? Vertical wall is your XY plane. No Z axis will take. And in that, the V is, right? On the wall, you can take it that your V is like this, making some angle with the P. Okay, so what is that some angle? Some angle is here. This is the angle theta. If this is the angle theta, then the component of V in the direction of magnetic field will come here. Am I right? And what it should be? Towards the theta, you know that. Towards the theta, how much it will be? V cos. I told you. Towards the theta, thumb rule I had given you, V cos theta. Otherwise also, if you just right angle triangle, you apply the trigonometry, you will get this. And perpendicular to the B, means other side, if I am taking my components, right? This is your component that will be in the y direction, we can say, right? And this will be your V sine theta, right? Call this as V1, call this as V2, okay? Got it? Up to that is clear. V1 is equal to V cos theta, the component of V in the direction of magnetic field. V2 is equal to V sine theta, the component in the direction perpendicular to the magnetic field. So now if we think in place of V, we are having V1 and V2. What will be the role of V2? Whatever earlier the role was, V2 is perpendicular to the magnetic field, then V cross B will find that is the direction of the force acting on it, and then is going to make a circular path. That is what we knew. So same thing V2 will do here. And what V1 will do? V1 will try to drift. Okay, this fellow is making the circular path, but V1 will try to drift it towards the x-axis, right? What I said, V2 will make the circular path, but V1 will try to drift it along in the direction of magnetic field B. So what will be the net effect? Net effect will be like a spiral winding. You know how the spiral winding is, right? You must have seen the, helical path. It means that you must have seen in the big notebook or project report you are making, the spiral windings are there. So same thing, that take it out, that is the same thing, that kind of path you will get. Okay, so this is going to make that is your helical path. And then finally the helical path, how it will look like, right? So if I take the helical path, my helical path will be projected like this. So it will start moving, and then it will go on this side, back side will be like this, start making the circular path. At the same time, it is drifting ahead. So going again, then next circular path. But you know what is happening here? The things has drifted towards the x-axis, and hence it will be just continuing. Here onward, they will just continue. So I have taken just 3. There may be many. So this way, the things are moving, that the particle is moving, correct? This is the path of particle. Okay, these are the path of the particle. Is it clear up to that? Yeah.
Yes, sir.
Yes.
Okay. So now in that case, suppose we go further. Here we'll talk about the various things, the radius of this helical path, right? Radius of this helical path we can find easily. Okay, and then we can find the other thing, that is your from peak to peak, right? I'll be taking that as peak to peak only. Okay, so if I take from peak to peak, that will be your pitch of the helical path. That will be your pitch of the helical path, correct? How come? That will come from this point. This is the peak to other peak. So this will be your, from here to here, we can call, this is my pitch of the helical path, right? Pitch of the helical path. So these two will have to find the pitch of that path of the particle. So R and this pitch will have to find. How to find R? As usual, we used to find the same way. We'll have to find here also. So R, if I am trying to understand, it is due to V2. Due to V2 is making the circular path, correct? So that if I take it, here it will be. Yes, tell me the equation. One end is your Fm, that is your QVB. So QV2B, that must be equal to, other end is your centrifugal action, which is your M, mass into acceleration. Acceleration is Vs squared, that is V2 squared. Due to V2 it is happening, divided by the R, the radius of this path. Understand, this is my radius R here. So well, I can have my R is equal to, you can check it, one of the V2 will go, and then same way we are going to have everything. So M V2 by QV, that is what we got it earlier. V2 is here, V sine theta. Okay, now I am replacing V is equal to, R is equal to M V sine theta divided by Q into B. Correct. This is what I'll be getting the expressions for your R, radius in which this helical path is being traced by the particle. Now, other thing like pitch, if you try to understand, before reaching to the pitch, one more thing we must see, and that is your, we can say that the time, correct? We'll be taking the basically the time period. How to find the time period, right? To get the time period, see, that is your capital T, right? And it should be, yes, time period, distance by velocity, correct? We have seen distance is circumference. So this is your 2 pi r, and then velocity, which is responsible for this circular path, is v2, always remember. So r, just now we got it, say this is your equation number 1. So from equation number 1, therefore, we can write your t is equal to 2 pi by v2, and here it is r is equal to, straight away I can take the upper one because v2 is there. Whereas I can take this as m v2 by q into v, right? The upper one we had taken. So well, v2 will go away, and then I'm going to have my t is equal to, time period is equal to 2 pi m by qv. That is same as the earlier case where the particle were projected perpendicular to the magnetic field. Same result, time period. So one circle it is making, that is the time. So then we can have consequently my frequency, which is your 1 by t, correct? You have to just make it to qv by 2 by m. And if I'm looking for my, say, I'm looking for your anything like omega, yes, angular frequency. This is your 2 pi f. So we can have 2 pi qb by 2 pi m. So well, I can have my omega is equal to, is 2 pi will go. So qb by m, right? So time period, frequency, angular frequency will be same. If you are remembering by formula, then you remember whether it is projected perpendicular or making an angle with the P, the time period, frequency and omega will be same. What is not? The radius. Radius will not be the same. Now come to the pitch. We'll just try to understand the pitch. That pitch, how to find now? Any idea? Anyone? Pitch of this helix, right? Helical path. Any idea anyone can give? This is the distance. How much distance that it is covering? So pitch, if I of the helix, if I take a d, yes, what way d will be there? Can you tell me? D will be your the velocity into the time. Velocity, distance is velocity into the speed into the time. So velocity in the direction of the motion is v1, correct? So I'll be taking v1. And how much time it is taking from peak to peak? Yeah. Okay. So now how much time it will take to just cover from peak to peak? Can you make it? Yeah. Can you make it? How much time it will take? How much time it will take? Yeah. Tell me. From one end to the other, from one peak to the other peak. By the time, you can check it, by the time this fellow is reaching to the next peak, it is making one circle also. You can see from here to here, that is the pitch distance. So by the time it is linearly traveling, the particle is linearly traveling towards the x-axis, towards the direction of B. This fellow is completing one circle, yes or no? So time taken to complete the one circle is the time here to be taken. So for the pitch, it will be d is equal to v1 into time period of this circular motion, this circle. So understood. So d will be your v1 is v cos theta into t, and t we can take it from here. The values you can put it, and my job is done. So please note it down. Once done, let me know. We'll go further.